let's do it again. Okay, explain this. This is the high and the low.
Okay, this right here, this would be sea level,
Okay.
and this is a low pressure,
Yep.
and this is a high pressure.
Okay.
And on a standard day, when it's everything is pretty much standard,
Yes.
it's straight relative to the ground. It's straight all the time, but it's never standard because every time you're moving, the pressure is always changing. So you're constantly, as you're flying the airplane, you're constantly manually adjusting your altimeter, because that's a pressure instrument,
Okay.
to inches of mercury.
Inches of mercury. Okay.
And on a standard day, those inches, it's 2992 inches of mercury
Okay.
is what the weight of the air column is. And that would be here. So you set your altimeter 2992. And we might say that the standard day would come in here something like this. Now, if you're in a high pressure, if we set ours to 2992,
Yep.
and we're in a high, and we were told that we had to fly at 35,000 feet.
Okay.
And we are in a high pressure, so this is where we want to be.
Right.
If we set our altimeter to 2992, we would be here. So we have to adjust our altimeter settings adjust for a barometric pressure, and we'll bring it up to like 30. Let's go 30.32. And if we adjust our altimeter from 2992 to 30, it'll push the instrument. Now will read what we actually want to be, which is 35,000 feet we want to be. So that's why we have to keep adjusting it.
Okay.
So now if we're flying from a high pressure or a standard day into a low, like a typhoon or a hurricane or something, inside the eye of that's an extreme low.
Yes.
We might be down to 28 something.
Okay.
So if we
That
set...
low? Okay.
Oh, yeah, that's a low pressure, 28.
Okay.
So if we had our altimeter set at 2992,
Yep.
and we were at this altitude, well, we're not this altitude. Let's forget about the 30,000, and now let's use this example as we're coming into a tornado. We're not a tornado, but a
Hurricane.
hurricane or
Yep.
typhoon. If we had our altimeter set here, and we follow that line down like this,
Yeah. I'll go that
it's going to
close
put
to-
us right
Right.
into the ground. So we have to set our altimeter to 28 something, which brings us back up to this line. See,
That's
we had
still
the 30.
very close to the earth or to the ocean.
Well, but we used to penetrate at 1,500 feet. So
that's
that's really close.
That is really close.
So we didn't have time, and because the airplane is shaking so much, the pressure instrument for altitude doesn't work. So we had a big radar altimeter, and it was very similar to the original fish finder, the Lowrance, which was just a round circle.
Okay.
And at the top here was 0. And then it would send out a pulse, a radar pulse, down to the ground.
Okay.
Had nothing to
The
do with
depth,
pressure.
Right.
And it would bounce back, and then it would give us a blip like this. And these distance here would tell us how high we were above the Earth.
Earth. Okay. Would it do
Precisely.
Okay. The bleep. The blip.
The bleep.
Yep.
So this is what we had. And that instrument was down in the plastic, the window, or our nose had plexiglass all around it, and that's where the meteorologist sat.
Okay.
So he was telling us what our altitude was when we were going in all the time.
Okay.
Now the only other thing that we really had to be concerned about was our airspeed, because that's what
Well,
keeps the airplane flying.
Sure.
But that's not affected by the pressure changes, because horizontal air is air. So you're going into the air, so we get that from a PDOT tube, which measures the velocity of the air going into the tube.
Okay.
So
So
we
now
didn't
what
have to
about,
worry about that.
you didn't have to worry about that.
So
but-
the only two things we had a concern about is how high are we above the
Yep.
water,
Yep.
and what's our flying speed.
But you also had to concern yourself on if you were in the middle of the hurricane, how to get out of it. Or,
Well, it's the same thing. Well, we have
did you
radar.
get
We
out
have
of it?
radar in the nose of the airplane, and we tried to pick out the weakest spot, and we try to fly through that if we can find it.
obviously you found it.
Well, no, not really, because
Well,
like
you
I
got
mentioned,
out.
like I showed you about with the tree.
Yeah.
Said it.
Yeah.
Because we were down, like, just think of yourself again in the forest. If you're walking on the ground and you're looking in the wintertime is a great time to do that. You see how much space is between the trees.
Yeah.
Well, it varies when
Yeah.
you're looking at it. Sometimes there might be 4 feet.
Yep.
Sometimes there might only be 2 inches.
Right.
Well, you pick up that difference in the radar, so you head for the spot that's 4 feet
Yes.
instead of 6 feet.
Okay.
That's the example. Obviously,
Right.
the airplanes are wider than 4
Yeah,
feet,
yeah.
but that's
yeah.
but that's the theory. And then when you get into the eye of the storm, we had to use just regular manual instruments to figure out what the wind was and our compass heading. So we would go into the storm, and if you look at this, I'll flip this over. Sometimes when you got into the eye of the storm and you like this, you actually had a just hole like this,
Okay.
and you could look straight up in that hole and you'd see blue sky.
Oh, that's amazing.
And then the
Okay.
wind, but the wind's on the surface because you got all of this convection going up.
Yep.
That's coming up. So what it does is it changes the wind then, depending on where you are in the center of this storm.
Right.
So when we would come in, and we'd always penetrate we always penetrate in the. Well, let's do it this way. This is the
The eye of the
eye
storm.
of the eye of the
The
storm.
eye of the storm. Yep.
If the storm is moving in this direction, we would then take a line like this, and then perpendicular to that, this is the way the storm is moving. We would always come into this and enter on this side and go out on this side, because this always is the weakest
Part
spot
of the storm.
of
Sure.
the storm.
Why not
This
over,
quadrant.
Why not that one? Over
Think
here?
of this storm as a big old snowplow.
Because it's going in
It's
it
going,
going-
no, in the northern hemisphere it goes
oh,
counterclockwise.
It's counter. Okay.
So as this storm is coming this way, these winds are going this way.
Oh, okay.
Think of this as a big old snowplow.
Yep.
This is kind of a vacuum type of thing. It isn't really, but I mean, and
Right.
that's why it's the weakest. So as the storm is pushing this way, and the wind is coming this way, now you got two forces
Yep.
that are pushing against this air over here. And when you get up to this spot over here, this is really a bad spot.
Yeah.
And then you get spillover here, just like when the low goes by and we got weather, and the low passes and it goes to the east, we still get rain and we still get snow and everything
Yeah.
like that until
That's-
after it's gone.
Okay.
So we always penetrated in the weakest spot. Now, sometimes the
So
weakest,
where would you turn around if the weakest spot was there? Where would you turn around? In the eye of the storm?
we always turn around inside the eye of the storm,
Okay.
because now when we get into the eye of the storm, and this is we came in here like this, okay, now we take up a cardinal heading to the direction of the movement of this. The storm is going this way.
Yep.
So we take up a cardinal heading,
Cardinal heading. Okay.
and then we had an optical drift meter, just like a binocular or a telescope,
Okay.
and we would have to go in the back of the airplane, and it's a tube that goes down with a lens on it, and we would pick up the waves. We know what our compass heading was, so we could figure out what our drift angle was. And that would tell us how strong the wind was pushing us off. Then we would take a 90-degree turn and do the same thing, another 90-degree turn, do the same thing, and another 90-degree turn, and we're back to the place where we entered.
Yeah.
And as we did this, we would check our drift all the way around. And then we got to the point where we could look at the water and really get good and estimate the velocity of the wind by looking at the waves.
That's phenomenal.
And it would tell you what all this stuff
And
was.
so ultimately, how high were you off of the ocean?
1,500 feet.
Always 1,500.
Yeah, that's what we tried
That's
to
your goal.
maintain.
That's your, yeah.
That's our goal.
Yeah.
But the storm had different ideas.
Well, always.
Yeah.
Yeah. And so you had to go in there 2 times every hour? Or how was it?
We made 2 penetrations every half hour. We made a penetration every half hour. So that's in and out. So that's 2 penetrations. And we did that twice. So that's a total of 4 penetrations per hour.
Per hour. In
And
an
we
8-hour
worked a lot
day?
of time on an 8-hour day. So that's 32 penetrations into that storm.
So once the storm subsided,
Well, we could tell by the wind. And then
so you were basically letting everybody know this is where it's headed.
yeah.
That was the whole idea behind all this.
Well, yeah, we'd know what we would.
So that you,
Yeah, so what we would do then is we would penetrate on the hour and the half hour, get our data, come back out, and then at 15 and 45 minutes on the hour, we would make a radio transmission to all shipping on a common frequency and tell them the exact location of the storm and what direction it was and the winds in the eye. So the navigator had to do all of this stuff and have it all ready
yeah.
and do all this stuff while you're being shaken and penetrating the storm,
Right.
so that when you got out, we could make this transmission, and we'd sit in orbit up there again until it's time to go back in again.
So when would you gas up?
We have
8
enough gas to do that.
For 8 hours?
Well, it depends on how far away the storm was.
Sure. And you were located out of where?
We were on the island of Guam.
Of Guam. Yep. That's where you and Ginny were, right?
Yeah.
One thing you did not say is to explain how you were able to read the spinning of you had to hold your feet down. It was like being in a tin in the airplane.
Well, sometimes it got so rough that you couldn't even pick out the instruments.
So you had to.
because you were being shaken so bad.
So then ultimately you did what?
I put my feet on the instrument panel, so you sync your vibrations as best you could with the instruments.
So
in
you
the
could read
airplane.
them.
Yeah, so you could tell the relative position of the needles. But the only 2 basic things we really needed was just airspeed and absolute altitude above the ground.
Yes.
Yeah.
To be safe and sound.
Yeah, because you got to know how high you are above the water.
Right, right.
Yeah.
Well, thank you, Jim Anderson. You're amazing. Thank you for your service.
You're welcome.